Welcome, I'm John Baker, and we're going to be doing some demos of specific functionality for NX9. In this case, we're going to be talking about a new function called Blend Pocket. Now in this particular case, what I have here is a part. Now I'm a designer, and this is a part exactly, I'd be perfectly happy if they manufactured this part just as you see it here. But of course this part's going to have to be machined. From looking at it, it looks like it's going to have to be machined out of a billet, which means that there's going to be a cutter that's going to have to remove the material, and unless you use a particular very expensive type of cutting operation, you're going to be leaving in essence blends around the edge of the pocket and around the various features here on the face of this. The issue here is though is that as a designer I may not really appreciate exactly what the results are going to look like based on the cutter. I can't maybe visualize that, and so if I start putting blends in here just willy-nilly, they may not actually represent what's going to be manufactured. So I'd really have to be kind of familiar with manufacturing. But there's a better way of doing it. What we've done is we've actually created a new function called a Blend Pocket, where we've taken that technology, we've actually taken the understanding, the ability, knowing how metal is removed, and based on the size of the cutter, so here I can define over here the type of mill. We have a couple of different options here that I can put in the size of the mill, so I may have to at least coordinate a little bit with the manufacturing engineer as to what the preferred tooling size is, and I can describe even the type of cut. So in this case I'm just, and we have, and it shows here, there's little examples showing what that would look like. So now I simply do is just to make one single pick, and you can see that all of the blends are created automatically. And this will really represent what the part would look like after being cut with a 20 millimeter diameter cutter with a 5 millimeter radius. And so as you can see, in order to machine around this little feature here, it had to machine up, over, and leave material behind. Obviously the cutter was too big to go between these features, so it had to follow this profile. So actually this material has actually been added to the model in order to represent what the real end part would look like. So the advantage that we see here is really several-fold. One, it's very fast, so that I can completely blend this part in really only one selection, and it represents what it's actually going to take to manufacture it. So again, this is going to speed up the process. It's going to be more efficient. The manufacturing engineer, when he gets this part, all he has to do is just check to see what size cutter that I use. In fact, he could make adjustments if need be. But the idea is this is a nice, quick, easy way to work. Thank you very much.